We're going to practice integration by substitution. So basically, we're trying to find the antiderivative of the stuff inside. So in this one, I'm going to let u be x minus 7. Oh, come on, pen. Let's work here. And so du, the derivative of this side, du, would be, or du dx if I'm taking it, but and the derivative of this side would be 1 dx. The derivative of this is just 1. So du and dx are equal. So this would be the integral, and this is u to the third, and dx is the same as du, so I can replace it, so it'd be du. And so to integrate u to the third, it would be 1/4 u to the fourth plus c. And now replacing the u with what we made the substitution, x minus 7, we get 1/4 x minus 7 to the fourth plus c. 2. I'm going to let u equal 4x minus 7. Derivative of this side would be du. The derivative of this side would be 4 dx. So, if I solve for dx, dx would be 1/4 du. And so this integral would become the integral of u to the third, and dx is 1/4 du. The 1/4 comes out, and then integrate u to the third, like we did before, becomes 1/4 u to the fourth, times another 4, so we get 1/16 u to the fourth plus c. Replacing u with what we used for the substitution, we get 1/16 of 4x minus 7 to the fourth plus c. Okay, the next one. I'm going to let u be the stuff inside the square root, because sums inside of square roots are not nice. U equals x squared plus 1. Derivative of u would be du. The derivative of x squared plus 1 would be 2x dx. So dx would be du divided by 2x, solving for dx. So then I'm going to have this integral would turn into the integral of x square root of u, which is u to the 1/2, because that's what I had u is. And the dx is du over 2x. These x's would cancel, so I get a 2 in the denominator, so I get 1/2. And then u to the 1/2, if I add 1/2, it's 3/2. So I have to divide by 3/2 or multiply by 2/3 u to the 3/2 plus c. Now reverting back to x's, replace the u with x squared plus 1, and I get, and these 2's cancel, so I get 1/3 u, which is x squared plus 1 to the 3/2 plus c. And 3/2 would be x squared plus 1 times the square root of x squared plus 1, because this is 1 and 1/2. This to the 1 would be x squared plus 1, and then the 1/2 would be the square root of x squared plus 1. So I could write it that way too. This is awfully blurry. Let's see if I can get this a little bit more focused. That's a little bit better. Okay, let's go to the next one. Kind of a messy thing, but I kind of recognize this as being related to the derivative of that. So I'm going to let u be that stuff. U is going to be x to the fourth plus 4x. And I think you'll see what I mean when I said that. So du, the derivative of this side, equals, and the derivative of this side would be 4x to the third plus 4 dx. And if I solve for dx, it's going to be du over this, but I can factor a 4 out of that and make it 4 times x to the third plus 1. That's what I saw going to happen. So this integral will become x to the third plus 1. I'm not replacing it. I am replacing that stuff with a u, sine u, and the dx becomes du over 4 times x to the third plus 1. Those x to the third plus 1s fortunately cancel. This becomes a 1/4 on the outside, so I get 1/4, and the integral of sine is negative cosine of u plus c, and now I'm going to replace u with what my substitution was, so I get, and I'll put the negative outside, so negative 1/4 cosine of x to the fourth plus 4x plus c. Next one. I recognize that the derivative of this is going to create an x cubed, and this is going to go away, so, and that's what that is, so I'm going to let u be the stuff inside this root, this power. So I'm going to let u be 4 minus 2x to the fourth. The derivative will be, the derivative of 4 is 0, the derivative of minus 2x to the fourth is minus 8x to the third dx. Solving for dx, I get dx will equal du over negative 8x to the third. So this integral becomes x to the third. I know that's going to cancel, so I'm leaving that alone. And this is u, so it's going to be u to the 5/7 and du over negative 8x to the third. My x to the thirds cancel, so I get negative 1/8 on the outside, and this just becomes, let's write this, negative 1/8, the integral of u to the negative 5/7 du. Integrating that, adding 1 to that, which is 7/7, I get 2/7. So I get negative 1/8 u to the 2/7 divided by 2/7, which is times 7/2 plus c, and then replacing the u with what I had, so this becomes negative, 7/16 u, which is 4 minus 2x to the fourth to the 2/7 plus c. I don't like that, so blurry. Okay, there it's in focus. That's better. Okay, this one. All right, so I'm going to let u be the stuff inside the square root, which would be 4x minus 1. Since it's power 1, this will be a simple derivative. Derivative of u will be 4 derivative of dx. So dx will equal 1/4 du, dividing both sides by 4. So this becomes the integral of u to the 1/2, and dx is 1/4 du that 1/4 comes out, and the integral of u to the half would be 3/2 and divided by 3/2, which means multiplied by 2/3 u to the 3/2 plus c. So then I get, replacing the u again with the 4x minus 1, and I get, let's see, 2 goes in there, so I get 1/6 u, which is 4x minus 1 to the 3/2 plus c. Looks like I'm going to do the same u substitution on this one. So I'm going to get this for this one. So what happens here? So I'd have the integral of x and u to the 1/2 and d 1/4 du. I still have an x. I can't have that. So what can I do? Well, I'm going to go back to my u here. U was 4x minus 1, and I'm going to solve for x by adding 1 and then dividing by 4. So I get u plus 1 over 4 equals x, solving for x in that equation. So I can replace my x with this. So now this becomes the integral of x, which is u plus 1 over 4 times u to the 1/2 times 1/4 du. So the 4 and the 4 make a 16th out on the outside. So this becomes 1/16. The integral of, and u to the 1/2 times u would be u to the 3/2. And u to the 1/2 times 1 is plus u to the 1/2 du. And that I can integrate, and I get 1/16. 3/2 would be, go to 5/2, so it'll be 2/5 u to the 5/2. And this would go to 3/2, so it'd be 2/3 u to the 3/2 plus c. Then I go back and replace the u, and I get 1/16 parentheses 2/5 of 4x minus 1 to the 5/2 plus 2/3 of 4x minus 1 to the 3/2. Close the parentheses, 16 times that, all that, plus c. Next one, similar process. I'm going to let u equal the x plus 1. du is going to equal dx. And I think I'm going to solve for x, which should be, subtract 1, u minus 1. So this integral becomes, see, I don't have any x to cancel that x squared, so I'm going to have x squared, which is going to be u minus 1 squared, times the square root of u. du is dx, so those are the same. So I have this. So I'm going to square u minus 1, which is going to be u squared minus 2u plus 1, FOILing that out, times the square root of u, which is u to the 1/2. I have to integrate that. So that's going to be u to the 5/2 integrated, going to be u to the 7/2 times 2/7. This is going to be u to the 3/2 and a minus 2 times u to the 3 halves will go to 5 halves, so it's 2/5 u to the 5 halves, plus u to the 1 half will go to 2/3 u to the 3 halves. Oh, and plus, not mine, equals plus c. And then I have to go back and replace all the u's with x plus 1. So it's 2/7 x plus 1 to the 7 halves minus 4/5 x plus 1 to the 5 halves plus 2/3 x plus 1 quantity to the 3 halves plus c. Oh, what a mess. Well, hopefully this is not so messy. Let's see, the derivative of cosine is negative sine. That would cancel one of the signs. I don't like that. If I let u be sine of x, its derivative is cosine. That would cancel the cosine, and I'd still have just u squared. So I'm going to let u be sine x. Du would be cosine x dx. So if I solve for dx, which is what I have here, it would be du over cosine x. So I would get the integral of u squared, because sine x is u, and we've got a cosine x, and dx is du over cosine x. Cosine x is canceled, and the integral of u squared is just 1/3 u to the 3rd plus c. And we go back to what u was, which is sine x, so it's 1/3 sine cubed x plus c. Okay, number 10. This one's not so obvious. See, 1 over cosine is secant squared. That's the derivative of tangent. So I'm going to let u equal tangent x. Du is then secant squared x dx. And I'm going to let solve for dx would be du over secant squared x, or secant is 1 over cosine, so this would be cosine squared x du. So this would become the integral of tangent is u, so u squared over cosine squared x, and the dx is cosine squared x du. Fortunately, the cosines are, so I don't have any x's. Just have to integrate u squared, which is 1/3 u to the 3rd plus c. So it becomes 1/3 tangent to the 3rd of x plus c. Okay. So, see, 1 over cotangent. Cotangent denominator is tangent in the numerator, and secant is the derivative. Oh, I think I'm going to let u be tangent x. So du would be secant squared x dx. And I could solve for dx, but I see secant squared x dx. So all of this is just du. And this is 1 over u, or moving that up, cotangent into numerator would be tangent. So this is just the integral of u du, which is 1/2 u squared plus c, which, replacing the u, becomes 1/2 tangent squared x plus c. So it helps to know your trig identities to do these. This one, the derivative of this will be 2x. So I'm going to let u equal x squared plus 9. Du would equal 2x dx. So dx would be du over 2x. And I can see that replacing the dx, the x's are going to cancel, and I'm going to get the integral of x over the square root of u, and dx becomes du over 2x. The x's cancel. The 2 comes out as a half. So I got 1/2 the integral of u to the minus 1/2 du. The square root in the denominator is u to the minus 1/2. Integral of that is add 1, be 1/2, so we divide by 1, which is 2. Divide by 1/2, which is multiply by 2. U to the 1/2 plus c. The 2 and the half cancel, so I get u to the 1/2, or just the square root of u plus c, and this u was this, so it's the square root of x squared plus 9 plus c. Okay, we can take the derivative of ln's, but the integral of ln's are tough. However, if you let u be ln x, the derivative becomes 1 over x dx, and if you solve for dx, you get x du. So, this integral becomes u squared, because u was ln x, over x, and the dx is x du. The x's cancel, and we get the integral of u squared, which is 1/3 u to the 3rd plus c. And so it's 1/3 ln x cubed, not just the x cubed, but the whole ln x cubed plus c. And of course, this would have to assume that x was greater than 0. This one, the derivative of arctangent is a 1 over 1 plus x squared. And I see an x squared plus 1, so I'm going to do u as the arctangent x. So du would be 1 over x squared plus 1 dx, and solving for dx, I get dx equals, multiplying both sides by x squared plus 1 du. And so this becomes the integral of u to the 3rd over x squared plus 1 times dx, which is x squared plus 1 times du. The x squareds plus 1's cancel. The integral of u to the 3rd is 1/4 u to the 4 plus c, which u was that, so it would be 1/4 arctangent x to the 4th plus c. 15. Cosine x, and then the cosine of the sine x. The cosine is the derivative of sine, so I'm going to let u equal sine x. So du would equal cosine x dx. And if I wanted to solve for dx, it would be dx equals du over cosine x. So this integral becomes the integral of cosine x, and then cosine of u, and dx is du over cosine x. Cosine x's cancel, everything is in u, and it's just simply the cosine u integrated would be sine of u plus c, and replacing the u with sine x, it becomes the sine of the sine of x plus c. Not often do you see sine of sine. What do we do on this one? Well, I don't like that square root. I don't want to, and the derivative of secant squared is going to be really messy. The derivative of secant is secant tangent. I don't see a tangent. So I'm going to go with u equals square root of x. So then du would be, so this is x to the 1/2. The derivative would be 1/2 u to the minus 1/2, which puts square root of x in the denominator, dx. If I solve for du, I get du is equal to, or for solve for dx, I'd have to multiply by 2 square root of x. Wait a minute, so 2 square root of du equals dx, solving for dx. I said that backwards. Okay, so that's solving for dx. Multiply the du by that. Okay, so now I got the integral of secant squared u and over the square root of x, and dx is 2 square root of x du. So the square root of x's cancel, so I'm all in u's. The 2 can come out. That's in the numerator, so it'd be 2 integral of sine of u, a secant squared of u. See, secant squared is the derivative of tangent of u plus c. So we have 2 tangent square root of x, that's what u is, plus c. Okay, secant x minus 1 and secant tangent. Secant times tangent is the derivative of secant. So I'm going to let u equal secant x. In fact, I'm going to let it be secant x minus 1. Then the derivative of this, the derivative of 1 is not going to show up, so I'm going to get du, derivative of secant is secant x tangent x, derivative of 1 is 0, so dx. And so I could solve for dx, and it would be du over secant tangent, but I can also just say secant tangent times dx is du, so all of this is du, and I'd have, this would be just u, so I have the integral of u du. So this messy stuff with this u substitution became just simply this, which is 1/2 u to the 1/2. No, what am I doing? 1/2 u to the 2. U to the 2 plus c. And so this becomes 1/2 u is secant x minus 1, close parenthesis, squared plus c. So what looked messy, the right choice of u makes it pretty easy. This one, we don't like to have ln in the integral. So again, we're going to let u equals ln x. So du would equal 1 over x dx, multiply both sides by x, and du times x is dx. Okay, so this becomes the integral. The 3 can come out. That's a constant. It's in the numerator, so it's on top, not 1/3, but 3. And we have an x, and we have u to the 4th, and dx is x du. X is canceled. Yay, it's all u's. This is u to the minus 4. So this becomes 3, and u to the minus 4, add 1, be u to the minus 3, divided by minus 3. And the 3's cancel, so I get minus 1 over u to the 3rd plus c, which is minus 1 over ln x quantity to the 3rd plus c. Again, we've got an ln. Don't like it in an integral, so I'm going to let u equal ln x again. Du equals 1 over x dx, or dx equals x du. And so we have the integral. The 3 can come out. And this will be 1 over x times u, and dx would be x du. X is canceled. Yay. The integral of 1 over u is ln u times the 3, absolute value of u, plus c, which becomes 3 ln of my u, which was ln x, so of ln x, and this is an absolute value, plus c. And finally this one. Ooh, we've got ln of something. Don't like the ln of something. So we've got u equals ln of sine x. So du will be, see, the derivative of ln of something is 1 over the something times the derivative of the something, which is cosine of the something, dx. So dx equals, this is multiplied by the sine and divided by the cosine, so it's going to be sine x over cosine x du. So this is the integral of cotangent x, that's u, and dx is equal to sine x over cosine x du. Well, cotangent is cosine x over sine x times sine x over cosine x. These are going to cancel. So I just have the integral of u, du, which is 1/2 u to the squared, plus c. So this is going to be 1/2 ln of sine x plus c.